Hi, this is John Morse at Project Blue. I went to visit our colleagues at UMass Lowell, Supriya Chakrabarti and Chris Mendillo, to get an update on their balloon payload that is going to carry a coronagraph to high altitudes in order to look for Jupiter-like planets around Epsilon Eridani. And so I hope you enjoy this update, and we look forward to talking with you in the near future.
Okay, so this is the telescope and instrument for Picture C in a intermediate stage of assembly. This telescope, this main truss is made out of aluminum, holds the primary mirror back here, which you can see is on a flexure mount that has 27 pucks that are glued onto the back of the mirror. This is a 150-pound, 2-foot diameter glass mirror. It's an off-axis parabola. Down here we have a large flat mirror that reflects the light back into the telescope. Our secondary mirror sits up here on a 6-axis hexapod that allows it to align itself in flight. And then the coronagraph sits on this carbon fiber optical bench. This is 2-foot by 4-foot bench. So all of the coronagraph optics will sit on here. Right now we're doing some testing on the low order wavefront control and the system that will align the telescope in flight. Glenn here is launching a beam from the focus of the telescope, and it goes through the telescope backwards and then comes back through and comes onto a Shack-Hartman wavefront sensor that's sitting here. And he's using that wavefront information to move the secondary mirror around to align the telescope to get a good diffraction limited spot.
So I have two questions. One is, you're getting ready to ship, and so this is getting close to being ready to be used, launched on a balloon.
That's right.
And to be used for scientific observation. So which parts are shipping and which are staying for further testing?
Right, so in about a month we're going to ship the telescope truss itself, which is this white aluminum frame. And the primary mirror and the secondary mirror will go along with it, along with this back mounting bulkhead. And we'll ship that down to Wallops flight facility in Virginia. And what we'll keep behind is the instrument, which just sits on this optical bench. That needs a little bit more development, so we'll work on that here. And then in July, we'll bring that down to Wallops and integrate it with the rest of the telescope.
Okay.
To replace that, we'll put in mass model of this optical bench and the electronics that sit on the back end. You can see behind here is the electronics frame that holds all of the electronics that drive all the cameras and deformable mirrors inside the instrument.
And so how does the telescope actually point on the sky?
So that's done using a NASA system called WASP, which stands for Wallops Arc Second Pointer. It's a 2-axis gimbal frame that holds the telescope at one point, which is on this main mounting interface here. You can't see it, but there are two sort of hub interface axles where the motors for the pointing stage mount. And the entire payload has to be balanced on that one frame, so that if you held it right there, it would be completely balanced, because the pointing system can exert very, very little torque. And it does that in a way such that it can point very, very steadily on the star using a star tracking camera that can determine where it's looking in the sky.
And so it's hanging essentially upside down on a balloon, and then it gimbals in order to point at a target. And what's your target going to be?
We have a few for this mission. Our favorite target is Epsilon Eridani, which has a known dust ring at about 3 AU, which is similar to our asteroid belt, and probably a Jupiter-sized exoplanet orbiting in the same system.
Excellent. All right. Well, we'll be back to talk more with Chris and Professor Chakrabarti later on in the summer when they're getting ready to fly this mission.